Hello, Ananya. Am I audible to you?
Sir, good afternoon, sir. Can you hear me?
Hello, hello.
Sir, can you hear me?
Yeah, now I can hear you.
Yes, sir. Good afternoon, sir.
Good afternoon. Ananya, in yesterday's topic, do you have any doubt, any problem, doubt, or something?
No, no, sir, sir. Sir,
So, yeah, whatever.
the yesterday's class was clear, sir.
Your voice is a bit low. Can you just?
Sir, can you hear me now?
It's very low actually. I can hear you, but it's very low.
Is it better now?
Yeah, now I can hear you. Okay, so today, which topic we should start? Which chapter? Because we can either start relation function, or I thought that chapter easy. You can do it by yourself. We can choose some other chapter if you want.
Yes, sir. Actually, sir, we'll do some other chapters.
Other chapter. Which one? Binomial.
Yes, sir.
So we'll be doing binomial. Okay. So binomial theorem we'll be doing today. In binomial theorem, basically we'll be discussing how you can resolve the powers, right? Like two or three powers, you can solve it by using normal method, by using the proper opening of those. But if you have given higher powers, like 10 powers, 100 powers, then in those cases, how you have to solve those. So this is what we will be studying in case of binomial theorem.
Yes.
In a rough idea, I'm sharing my screen with you. I've shared with you.
Yes, sir, but it's, yeah, yes, yes.
It's what is it?
It's visible now, sir. Sir,
It's
it's visible now, sir.
okay. It's visible. The chapter is we can assume the chapter. Okay. So basically, this chapter is all about computation of higher order, higher order. Basically, here will be we have to solve powers. Okay. Powers. For example, if you have to calculate 93 to the power 10, 100 to the power 46 minus, if I say 10, 9 to the power 32. So if you have given these kind of equations, it's not an easy task for you to just go and do it 100 into 100 into so on till 40, like 40, 46, right? And then you subtract it using 109 into 109 till 30, two times basically. to compute this portion, to compute this portion, right? It's not an easy task for you. So then what we can do, we can apply binomial theorem in these kind of cases. Okay? Binomial theorem, it basically provides a simplified equation for the expansion of a plus b to the power n. Okay. So binomial theorem. What this theorem does is it simplifies the expansion. Okay? It simplifies the expansion of a plus b to the power n. Okay. Where I can say that n is some integer. Is that clear? Any doubt you have till now?
No, sir. Clear, sir.
We haven't uh, took into any depth right now. Okay, we are with very basic things. Okay, so I have some two numbers. Let's say a, let's say belongs to a rational number. Okay. One more thing, you can write this as a rational number. Okay. Rational number. You can say. Okay. So I have two numbers. Okay, a and b, and they belong to rational. And I have another number n, which is also belongs to. We can say okay, it belongs to integer. Yep, or you can say natural numbers. It belongs to natural numbers. Then what will happen? I have to calculate a plus b to power n. How I can calculate? I'm not sure. Let's do something. I know what is a plus b to the power 1. It is nothing but a plus b itself. What is a plus b to the power 2? A square plus 2ab plus b square. Okay. What is a plus b to the power cube? A cube plus b cube plus 3ab a plus. Is it?
Yes, sir.
But till now, where you will be remembering all these things. Here comes up a twist. Okay, we come up with a proper formula for that. What is that? A plus b to the power n. It is nothing but, again, look. What you have to do is start by choosing n c naught. Okay, n c naught. Okay, n is basically the highest power, and then you maybe you could remember or you can guess the rest of the thing. What I have to do? I have to take A, either B, whatever you want to put first. It's up to you. Either start from anything and take it from. Let's say I'm starting it from. Remove it from here. Put it R. Okay. Start this with either R n minus R or either with R. It's up to you. If you are taking this with R, the next one should be n minus R. If this is n minus R, the next one should be R. Is that clear?
Yes, sir. Clear, sir.
And this R should go from. You can also write. Let me remove it. Okay, so what I wrote, right? I wrote this thing, right? B n minus R. Do you know summation?
Yes, sir.
Okay, summation is basically then I have to write too many things like in addition, so I can try to make that into a function and put a summation after. So my R is going from 0 to n. Is that clear?
Yes, sir.
Now I'll try to apply the same formula for these two. Okay. Okay, so look here. What I have, if you see, I have two, right? Let's start with the two. I am at one, and so this is the maximum value you can put it at. This I have to start with zero, so put it zero. What is this? A to the power zero, so it is zero. B n minus basically becomes 2 minus 0, so it comes to plus 2c1 a to the power, what is it, 1, b 2 minus 1, it comes out 1, plus 2c2 a to the power 2b, I think it should be okay at the rest, the last is that clear? What you can see, I have taken this a from 0 to the final a, maximum power, and this b has been moved from maximum power to the 0. You can see this part, is that clear?
Yes. Yes, sir.
Okay.
Yes.
I think you don't know how. You do you know how to solve this and maybe this something?
No, sir.
Okay, fine. So I'll just fix that part also. Okay. Before moving further, I can go through that thing first. Maybe. Okay. Um, okay. So first I can tell you something new thing, which is Pascal strength. What is Pascal strength? Okay. So basically, the expansion coefficients, okay, if they're organized in a triangular shaped array, okay, at the top one should be there and running down with slanting sides. Okay, what I said, I'll be having a triangle where the top element will be one. Okay, and what I'm going to do, I'll try to organize them such that they run in this form. Okay, this is what my task is. Okay, in each case the first guy should be the first, like I can say the top of the Pascal triangle will be the first person. Is that clear?
Yes, sir.
Okay. We call this as a Pascal's triangle because we are forming a triangle. Okay, and all these elements, if I say this element, this element, this element, this element, all these are a coefficient of a particular, you can particular powers. Okay, if particular exponential. Is that clear? So I'll just again remove it and put some values over there. Okay. So how Pascal's triangles looks like? So basically, when I told I'll be putting one at the top of the stack. So this is my one. Okay. After this, what I'm going to do, I have to go in this way. I have to go in this way. Put one and one both side. Okay. Again, one and one both side. If you have space, put some of both. Some of these two. What we have got here? Till now, any doubt you have?
No, sir. Yes.
No doubt. Okay. This is for the, you can say, zeroth power. This is for the one. This is for the, you can say, two. Okay. We are going from top to bottom only. Now, can you imagine what I should do next? Look, I am going in this way, right? And I am going this way. What will be my next step? I'll be putting something here, put one here, and at here you can again put one. All right. Now I have two these elements, right? What should be here? It should be three. What should be here? It should be three. Make sense?
Yes, sir.
Okay. So here you'll be having one, three, three, and again the final is one. If you look, these two elements are there. In between, you can directly put four. Two elements are there. You can put six. Two elements are there. You can put sum of them four, and the last one comes out as one. Okay. So what you have figured out, if you don't find any other pair with that, you can directly put the one itself at the last, the element itself, because you can assume here you have zero. Is that clear?
Yes.
Okay. So that's, and here like so on, you can make these kind of Pascal triangle. Okay, so like wait, I can just put one more thing. For this you have five, this you have 10, for this you have 10, for this you have again five, and the last one is one and one.
Yes.
Okay. So let's go back and start with some powers. Look at some powers. If I'm writing a to the a plus b to the power 0, what does this mean? If you see, I'm saying my final answer is just a 1 with some coefficient, right?
Yes.
It means if I just go with a normal formula, NCR, okay, a to the power 0, basically r, b to the power r, what is n
Minus.
minus r, and I have to go from r equals to 0 to n, but here n is itself 0, it means just a single operation will be there. Okay, so I can remove it. Now what my task is, I told you this will give you the coefficient, right? This portion is for your coefficient. Understood this thing?
Yes.
Whatever the triangle is going to give you, this will result to the coefficient of it. Okay. Alright. So you got some idea that okay, in this first set I have only single person, so this whole thing will result to me basically it is nothing but n is zero, c is whatever. Okay, leave this for now. You have r. Okay, r is starting from zero, but it can max go to zero this time. Okay, so it becomes this, and you know this whole thing should be one because of my Pascal triangle of the top step person. So it comes out to be one. What is this? A to the power zero. Zero. It's by 1, and b to the power 0 minus 0, it again comes out to be 1 itself. Yes, so what happened? You have result at 1. Is that fine?
Yes, sir.
Okay. So I can say my this answer comes out to be 1. Okay. What about a plus b to the power 1? Now if you see carefully, I'll look, if my power is 1, I'll go to the second, whatever it is. Okay. Basically the indexing, we call it as indexing, you can say. It starts from the 0. Okay, we will not say like this is for the first power. It is for the whatever you can see, it is for the n minus 1 power. Okay. If you are saying for,
Yes, sir.
understood that point what I'm trying to say? Like if this is n, okay, so um, you can call it as n minus 1 for power. Is that clear?
Yes, sir.
Yeah. We were at 1. Okay. Now for 1, you have to reach here. Is that clear? Now if you see, you don't know how many elements are there, but you can see like only two coefficients are there, so there must be only two elements. Okay. So here, what is my n? N can be 1. And what can be the maximum value of r? R can go from 0 to 1. Is that fine?
Yes, sir.
Okay, let's go to the NC0 mean to say I'm going with 1C0. Another will be 1C. This is the only thing possible, right? So I can make two spaces here. 1C1. Okay, what can be here? A to the power 0, B to the power 1, plus A to the power 1, B to the power 1 minus 1 comes out as. Is that clear?
Yes. Yes, sir. It's good.
Okay. So Uh, if you see carefully, what is this? This is one, right? Why this is one?
The
Why
first,
this is one?
the first
Because
one.
of the, yeah. Okay. Tell me.
So I was just saying it's like the two boxes in the first one is one, so it will be one.
Yeah. If you walk through this stack of the Pascal's triangle, you can say, okay, I have only these options. Okay. So I can say this is one. a to the power 0 mean to say 1 itself, b to the power 1 mean to say b. Plus you can write it as 1 again, a to the power 1 is a itself, b to the power 1. So what you have got? B plus a. It is nothing but a plus b. Okay? You can write whatever you want. Order doesn't make any difference. Okay?
Yes, sir.
Now, if you see, let's, okay, you know this thing, right? So I know you know the power of this. You can do this. I'll just go through some other power. Let's say a to the power 4 we are going to. Okay?
Yes, sir.
B to the power. It's just 45 minutes. Okay. Here, what is my maximum value of n? So here my n comes out to be, I'm solving here, okay? So my n is nothing but 4. So my r is going from 0 to 4. Is that fine?
Yes, sir.
Okay. So let's start by one. I am at 4, C 0, R 0. Mean to say, better is now if you like. I'll just tell you one thing. If you start by taking the second guy as 0 and the first guy as maximum, then it will give you a better order, right? You can see I am
Yes, sir.
taking the first person as 0 and other as highest power. So finally, we are getting a reversed order. Are you getting a point?
Yes,
So
sir. Yes,
at
sir.
the end of the day, it's just a summation. So final answer doesn't make any difference. But to see to look it better, what you can say, okay, you start with a to the power n and b to the power z. Okay,
Yes, sir.
so it's 4 b to the power 0. Mean to say this method plus 4c1 e to the power 3 b to the power you can say 1 plus 4c2 plus a to the power 2 b to the power again 2 plus 4c1 plus I think it should be 3.
Yes,
A to the power, it is 3 a to the power 3 b to the power, wait, I started with 4 3 2, it should be 1 actually. 1 b to the power 3 plus 4c 4 a to the power 0 b to the power 2. What you have what you can see, I am for decreasing for 1. It is multiplying. Okay. Okay. I am decreasing for 1 and increasing for another. Let's say here it was b to the power 0, so it is going. It is kept on increasing, right? Is that clear? Okay. By seeing this thing, I know it should be 1 4 6 4 1. Just take all these 1 4 6 4 1. Okay. So what your final answer will look like? 1 is there, so we don't have to write that. I can write it as 1 a to the power 4. 4 times of a cube b1 b basically. Another is 6 times of a square b square plus plus 4 times of ab cube plus b4. Right? This is what my final answer looks like. And doubt you have in this case?
sir. Yes,
If you notice one thing, what happens now? Whatever time if you see the summation of the powers of both, okay, summation of power of both result to the maximum value n. Right? You can see here it is 4, here it is 3 plus 1 4, it is 2 plus 2, here 1 plus 3, here again 4 plus 0. Right?
yes, sir.
So these things are there. So I think now you understand how to solve this thing using Pascal's triangle. But the thing is, for an example, how you will be creating Pascal's triangle for a very long time, right? So for that, let's do another thing that is called combination. Okay. So we have something called a combination method we use. When I'm writing something like NCR, what does this mean? It means factorial of n divided by factorial of r divided by n minus factorial of r. Okay. Now again, I gave you the formula for this thing, but I have introduced one more term which is called this, right?
Yes, sir. Sir, I
So
know what
this
is
is
factorial.
what happened.
Sir, I know what factorial is.
You know factorial. That's more than enough. Okay. So what you have to do, you just have to solve this part, right? Okay. So let's take an example of 4C2. I can take. So here I have 4 factorial divided by 2 factorial and divided by n minus r factorial, means to say 2 factorial itself.
Correct.
So this 4 factorial can be taken as 4 into 3 into 2 factorial, right? So
Yes, sir.
2 factorial into 2 factorial cancelled out. What I have left with 4 into 3 divided by 2 into 1 kept. You can see 6 answer is there, and you have got the what is there
Mm-hmm.
for this one, right? We took 6 as an answer, right? So
Yes,
that's the
sir.
thing. Okay. It's basically says that how you are what combinations you are choosing out of whatever the elements you have given. Okay, which how in which way you are going to choose the elements. So that's what it says. And another thing we have called permutation. If you see npc, npr, it means n factorial divided by it is n minus, okay, it is r factorial. Okay, but in case of ncr it is n factorial r factorial n minus r factorial. Is that clear? Any doubt there?
No, sir. True, sir.
It's fine, right?
Yes, sir.
Okay.
Sir, just
So this what
the,
happened?
the difference between permutation and combination is that permutation takes the order, but combination does not.
Wait, just a second. Okay, it should be this. Yeah. Anya, your voice is a bit low. Like I think it's a bit low or what? I'm not sure. Can you just try
So
to
can
increase
you,
it?
sir, is it better now?
Yeah, now it's better. It's better now.
Yeah, so can you explain the difference between like combinations and permutations, sir?
Yeah, exactly. Okay. So just first of all, just remember these two formula. Okay. I'll just
Yes, sir.
remove this now. I'm removing it. Okay? Let's write again. Let's say you have two numbers. Basically, what happens, permutation and combination is another chapter for you itself after the binomial. Okay. So in permutation, what we do, in permutation, we try to get the order of arrangement. Okay. Here, order is also important. For example, if I tell you, you have what I can say, you have red, blue, black, gray, and yellow. These balls are there, okay? And I am asking, get me the two balls. Get me the two balls, okay? And maybe color might be same or different. I can say, let's say I'm saying different color should be there. So you can say, okay, R and B, right? Red and blue can be there. Red and black can be there. Is that fine?
Yes, sir.
So here what I'm taking, I'm just taking combinations. Okay, I can take this combination. So if you see carefully, if I'm taking this combination, whether I take black and red black, it doesn't make any difference, right?
Yes, sir.
So this is what the combination says. Combination says, get me, let's say 5 is there, right? 5 CR. Okay, how many ways are there so that I can extract out two balls out of the 5 balls? Understood my point? This is what the
Yes,
combination says. It says how many combination I can make of the two elements out of these given 5 elements. But here comes another twist, which is permutation. Permutation says, okay, that is fine. You can make the combination whatever you want. But I need one more thing. What is that? In what ways you are trying to do it. For example, in this case, if I'm saying what are the arrangement. In case of permutation, if you see carefully in combination, I was just interested to get to know how many possibilities are there to have combinations. Okay, I was not interested in which arrangement they are. For example, for me, red and blue, red and blue, and blue and red was a single combination, right?
yes, sir.
But when permutation comes up, it checks upon the arrangement. In which arrangement are there? Okay, so for if you see with respect to perspective of permutation, red blue is one arrangement, Blue red is one arrangement. Okay,
Yes, sir.
it's like queue wala thing. Okay, it says okay, let's check who is first on the queue, who is the second on the queue. Okay, then I can say okay, if they are same, then I will say okay, it is same. Otherwise, even the thing are just reversed, still I will say it is different. Understood? For
Yes,
case of combination, you will call it as one, but in this case, you will call it as two different cases.
yes, sir.
Is
Got
that
it.
clear? That's why if I say, if you know what is the combination, like how many combinations are there, so you have to calculate this first. So let's say I calculated how many combinations are there, that is n minus 1, n factorial divided by r factorial. Okay? This is what I did, try to do. But how I'll be calculating, in how many ways I can select.
So
Okay, wait, I think
basically,
this
you mean,
n minus r factorial divided by an r factorial. Okay, this is the formula for the combination, right?
yes, sir.
This is how I got the combination. But I have two elements, right? For example, these two elements are there. Okay, let's say these two places are there. Okay, either I can place R red here, either I can place blue here. Is it?
Yes, sir.
Now, if I ask you how many ways are there to present it, you know, for the first place I have two options. To I can put two out of anything. Is it?
Yes, sir.
If I put two, like one out of two, how many elements I will left with? I will only left with one, right? So how many total options I have? Two into one. So can I say it is nothing but the two factorial itself?
Yes,
Okay, I'll just go with a more better picture. Just assume I have 100 boxes. Okay, 100 boxes, or you can say 100 different shades of colors. 100 different shades of colors. What I want to take five colors out of this 100. So if you just go with a combination, I will say, okay, make combinations. So what are the possible combinations? It is n 100 times of c times of 5. Is that clear?
yes, sir.
These were number of combinations I can make. In the combination, for example, if I am taking red, green, blue, yellow, violet, now this or red, blue, yellow, green, violet. If I'm making combination, these things will be counted as a single entity. Is that clear?
Yes, sir.
Because in combination, we are not interested to get to know the what I can say,
You order
arrange,
in.
order and arrangement. Now, if I get to know that okay, these many numbers are possible, so if I can get the order, the possible arrangement for each of the combination, then I will get the permutation also. Is it clear?
Yes, sir.
So how many elements are there? I have five elements. Okay, so how I can get the arrangement, possible number of arrangement? You know, I have five places to fill out, right?
Yes, sir.
So you know, I have five distinct. Look, one thing. Right now, I'm taking the case when all the colors are distinct. Okay,
Yes,
there will be some different cases also where you have a same. Like for example, red is there. Okay, so you know, red and red doesn't make any difference, right? Taking red and red.
yes, sir.
I'm not taking those cases. I'm taking those cases right now in which all the elements are distinct. Okay. So what I'm saying, you have five options right now. In the first group box, how many options you have to fill?
Two
Five
of.
options. Five options is there, right?
Yes, sir.
If you fill one, like if you choose one box out of five, how many of them are left for you to fill other four places?
Four.
Four options will be there. Now I will be reaching here with the four options only. Out of these four options, I will use one here, and I will left for three options here, two options here, then one option. Is that clear?
Yes, sir.
For each of the five option, I will be having these many arrangement. So I will be multiplying 5 into whatever arrangement I am doing. For each of the four arrangement, I will be having these many of the arrangements. So I will be multiplying it. For each of the three arrangement, I will be having these many for two many. So you can see I am multiplying it for 5 into 4 into 3 into 2 into 1. And isn't it this 5 I have taken here? So can I say I am taking, if it was 100 CR, I am taking uh, here as R into r minus 1, r minus 2, till where I am going? I am going till it comes out to be 1 itself, right? So can I say it is nothing but r factorial?
Yes, sir.
Okay. So you can see these many numbers of arrangement I can make. If I can make these number of arrangement, I should multiply it for the each of the possible number. For example, I had 10 ways. Basically, I had 10 combination, and for each combination, I have these many possibilities. So should I multiply it with this 10?
Yes, sir.
So will my final formula will look like 100 CR for the combination multiplied by number of ways you can arrange them. Is that clear?
Yes, sir. Clear, sir.
So can I say it is nothing but NPC, NPR? If you again just make the formula, it will become R factorial into what is this value? It is N factorial divided by R factorial. Okay, N minus R factorial, and you can see what you have got again. N factorial divided by this is the formula. Clear?
Yes, sir.
So your permutation contains two things: numbers of possible arrangement of each combination, number of possible arrangement of each combination multiplied by total possible combinations. Does it make sense?
Yes, sir.
Total possible combinations.
Yes, sir.
So this returns you the computation finally. So I'll be just writing in a final sense what is the formula. If I'm writing combination of R elements out of n, so it will be nothing but it will result NCR n factorial divided by R factorial, and it is n minus R factorial. Okay, permutation or permutations of R elements out of n will be nothing but arrangement of each combination multiplied, multiplied by possible combination. Okay, possible number of combination. So the same thing, whatever you have got in the final, r factorial multiplied by n factorial divided by r factorial n minus r factorial. It will result you something n factorial divided by n minus r factorial. Is that clear?
Yes, sir. Clear, sir.
Okay. If you see something, one more thing, 0 factorial is 1 itself. Okay. We don't, you don't say that 0 is 1. Basically, because after 1 we reach to 0, so it comes out with 1 itself. If you want, I'll just minimize the screen for a minute. You can take a look at this and let me know if you have any doubt or not.
No, sir. This part is clear, sir.
This part is clear, right? Okay. So we can move to the next thing. Okay. So if you're done with this, I think we have done most of the chapters. Okay, rest of the part is just properties and the problem solving, because this chapter is based on this thing itself. Okay.
Okay, sir.
All right. So let's calculate the general term and middle term in the expansion. Okay.
Yes, sir.
Right. So my expansion is nothing but expansion of some power is a plus b to the power n is nothing but it starts with nc 0 a n b n minus, okay, like it is 0, so on till where it goes n c n a to the power 0 b to the power n. Is it?
Yes, sir.
I want to calculate some general terms so that I will get to know, okay, this is my first term, this is my second term. Okay, is that clear?
Yes, sir.
So how I can do that? I need some idea like how I should do that thing.
So, like,
General, yeah, okay, tell me. A general term of a binomial expansion.
So like for example, if we a power r, then we can write it as um, like NCR
Okay.
and a power like n into b power n minus r like that.
Okay. Fine. So I can say that my general term is nothing but for any for general term comes out to be, if you want nth term, basically term you want nth term. So what it will be n c r you have to write because n is the maximum value in general. So it is nothing but n c r a to the power, you can write it as n minus r, and you can say b to the power r. Okay. So let's see. It's up to you, like how you are saying. For example, if in a to the power 8, this thing you have three terms, right? If you are
Yes,
saying I have three terms, okay, yeah, write it as first r plus 1, r plus 1. It means to say, if you want to calculate this term, right? How you can calculate? Put r plus 1 equals to 1, because you need first. Yeah, it means you have to put r equals to 0 in this equation to get this term. Is that clear?
yes, sir.
In this way, you can do this. One more thing, if you see, um, this is the now the next one is middle term calculation. How you can calculate middle term? I'll just go back to the Pascal's triangle. If you see the Pascal triangle carefully, what will you notice? For the, let's say this is the first, right? The first term which is I'm going to get, or you can say the power. If you see, what is the power here? The power should be zero. Here the power is what? 1.
One.
Here the power should be 2. Here the power is 3, right? If you see, for the odd power, I have total number of elements are even, right?
Yes, sir.
For the even power, I have total number of elements to be
Odd.
odd. So what I need middle element. Middle element are these elements. But in case of odd power, odd power mean to say the total number of elements are even. If total number of elements are even, I will be having two middle element, and if you can see, both the two middle elements have a same coefficients, right?
Yes, sir.
Okay. So what I can do is, I will say, okay, middle term first for odd power. Let's do it for the even power first. So for even power, what you know, the total number of elements are going to be, what kind of elements going to be?
The odd.
Odd, right? So total number of terms in expansion is odd. Okay. Therefore, the middle term, it will be what? It will be
Not.
nothing but n plus 2 by 2th term. Is that clear?
Yes, sir.
Why I'm saying, for, and let's take an example of n equals to 2. Power is 2, right? So n plus 2 by 2 will result you how much? 2 itself.
Yes, sir.
And you can see middle power is 1, 2, 1. 1 is 2. Second is the middle power. Okay.
Yes,
And this basically what happens, if you have n, basically whatever, how many elements are there? In that case, n this side, and one is the middle element. Okay.
yes, sir.
So when you do n plus 2, mean to say, this is n portion, okay, that is n portion. When you add 2 and divide, you will result here, okay.
Yes,
So that this is why we do it. Let's remove this one. Okay. So what is my general middle term in this case? Term will come out to be whatever it is, n plus 2 by 2 equals to, okay, great. Here my r will be this, okay. My r is going to be r plus 1 should be n plus 2 by 2. So my r will come out to be n plus 2 by 2 minus 1. So it is nothing but n plus, I think n by 2, right?
yes, sir. And like
It will be n by 2 itself. You can call it as n by 2. And I think it makes sense also. For example, it is given to, how much is given to you? For example, You
Yes, sir.
want to calculate, okay, I'll just take example of a plus b to the power 2 itself. Okay, I want to calculate middle term. I know this is the middle term, so here this n plus 2 by 2 comes out to be how much?
It'll be 2.
2 it comes out to be. So my
Yes,
middle term will, if in this method, if you see, what is my r comes out to be? R comes out to be how much?
1, sir.
1. Okay,
It'll be
yeah, it is 1 itself, right? I can put the value n c 2c1 a to the power 1 b to the power 1, and this value comes out to be 2.
2. Yes, sir.
Got the answer, right? Okay, yeah, that is fine. Okay, basically, if you see, for a general term, the main task was your, like this will be happening. Okay, here main task is to calculate r. But if you calculate r, you will get the value. Okay,
Yes,
for general term, whatever the thing you have to calculate. Okay, whatever the thing you have to, let's say you have to calculate second, it means your r should be 1. If you have to calculate 1, your r should be 2. Is that clear? Because you can see here that whatever the term you have right, it is written in the r plus 1 format. It means r is equals to whatever another number you want minus 1. Is that clear?
yes, sir.
And here, what in this middle term, what I am getting, r equals to n by 2. For odd, what I'm going to get? Odd
N
terms.
plus 1 by 2.
Let's see. So in the case of odd, what I should get? It will become, it will be having two options because you have two odds, right? For this side, for this side, you have two options. So if you do n plus 2 by 2, okay, you should reach somewhere here, but we don't have any option. Okay, we don't have any option. So what I need, either I need this, either I need this. Okay, so what I will do, either you can go with n plus 1 by 2, then you will reach here. If you do n plus 2 by 2, you will reach somewhere. Is this clear?
Sir, N plus 2 by 2, so you won't get an answer, right?
Look, the whole thing is odd, right? The term is odd. So if you do, let's say odd, I'm taking 3 plus 2 by 2, will result to how much? 2.5, right? We don't have 2.5, right? Either we have 2, either we have 3. Is
Yes,
that clear? So
yes, sir.
that's why I'm saying this n plus 2 by 2 won't make sense here because you will be reaching here in between 2.5. It doesn't have anything. Either you have 2, either you have 3.
Yes,
Make
sir.
sense?
Yes, sir.
So that's why for odd terms, what are the middle terms we have? We have two middle terms, n plus 1 by 2, 2th term, or what terms we have? N plus 3 by. Is that clear?
Yes, sir.
Okay. So what can be r possible if, okay, so I can say r plus 1 is nothing but r n plus 1 by 2. So n r comes out to how much? N plus 1 by 2 minus 1. So it comes out to be n minus 1 by 2. Make sense?
Yes, sir.
For the next, r plus 1 equals to n plus 3 by 2. So your r will result how much?
N plus 1 by 2.
Exactly, n plus 1 by 2. Clear?
Yes, sir.
And okay, let's take an example of odd term. How much? Okay, let's say a plus b to the power 1, the best example we have. Okay, what is n here? N is 1, right? So 1 plus 1 by 2. I'm taking this part. Okay, so here you can see it comes out to be r की value 1. If r value comes out to be 1, you will be reaching here. If you take this case, n minus 1 by 2, it means 1 minus 1 by 2. You will be reaching here. Okay, so this is
Yes,
the thing you have to do. Remember these things. Okay, nth term and middle, general term and middle term, and the exponential formula. Okay,
yes, sir.
in this chapter, I think too much part of the problem solving. So okay, look, I have completed the half chapter. I think I should stop here. Okay,
Okay, sir.
because this chapter is little bit big. So what you can do is, wait, let me check if some properties are there so that
Do you have any question bank for these question, like these this part, sir?
question bank I have, but those are J advanced level, so I don't suggest you to solve those. You told that you have some question banks.
Yes, sir. I have them, sir.
Well, okay, so basically try to solve those. I'll suggest, do you have NCRT book?
Yes, sir, I have, sir. Like, I mean,
Okay,
online.
so yeah, online, that's fine. Okay, whatever try to do, go with the NCRT. Wait, let me open the NCRT if I can. Open here, NCRT, binomial theorem maybe. I think this. Okay. Wait, I'm sharing with you for a while. Is this it? Okay, can you see this?
Yes, sir.
Okay, look here, too much things are written. Okay, so if you can understand, that's fine. If you don't, just leave the part. Okay. Again, it gives you just a definition, right? How you have to go with the expansion. Okay, one more thing. For factorial, there's two terminologies are there. One is this method. Okay, put an L sign before whatever the number you have. You can see here before n they have put an L sign, right?
Yes, sir.
One method is this, and another is that method which we were using, right? You can see they have given a general equation, some theory is given, and this is the you can see this is a Pascal strand, right?
Yes, sir.
Okay, some cases they have given, so you can read out these cases if you want, and this is just a way. Okay, don't go with this the pth term from the end. Okay, it doesn't make any sense. This is the middle term part. Binary coefficient thing is there. Where is the problem here? From here you can try to solve some of the problems. Okay, for example, examples are given. One example, second example, third example, fourth example, fifth example is given to you, sixth example is given to you, seventh example is given to you. How many examples are there? 8, 9. Okay, like more than 10 examples are directly given, so you can try and solve this. It will become an easy option for you,
Okay,
right?
sir.
Because you have given the solutions also, you have given the questions also. Okay? If you don't understand still, so you can tell me in the next class when I'll be taking. Although next class I'll be taking not today actually. I'll be taking on 16th directly.
Okay. Okay, sir.
Although I was not supposed to take class today, but yeah. So after this next class, I'll take on the 17th. Okay.
Yes, sir. Okay, sir.
I hope these parts I have already completed. Whatever they have taken in the example.
Yes, sir.
Look, they have like the part is simple. Just the complexity they have made in the problems which they have given. Okay. So try to figure out. For example, you can see this one. I told you in the first also, like how you will be solving these parts, right? So here the binomial theorem comes into play.
Okay, sir. Yes, sir.
Wait, how many? You can see too many examples are there. I think 21, 22,
Their excessive.
22 examples are there itself. Okay, one more thing. This is Z, basically the complex number. So if you don't know the complex number part, you can leave this problem. Okay,
Okay, sir.
the complex number. After completing this chapter, I will go with the complex number and quadratic equation. Okay, so
Okay,
it will be a better option for you. So just a second, let me check how many other options there is. Short answer type, long, objective, MCQ. Okay, fine. Basically, whatever we had done, that was the more than enough for the topic as per the NCRT. Okay. So in the next class, for from my side, some topics are still left. So I will teach you better solve as more as questions you can solve.
okay, sir.
Okay. So that's the thing. Then, just a second. I have to think of one. I'll suggest one more thing. Like if you see, we are working with powers, right?
Yes, sir.
Wait, I'm sharing my board itself. Can you see this?
Yes.
If you say some expression like you are getting a plus x by a or something, okay, so always try to figure out where we can neglect the things. Neglecting mean to say, you can say if my power is very high, right? My power is very high. Okay, and if you see something like a plus x by a, let's say x is very very less and it has a significant value. So for example, I am saying x is nothing but 1 and a is nothing but 10,000. So you know 1 by 10,000 will result very very small value, right?
Yes, sir.
And when you do the power of this in upcoming cases, so like for example, you are expanding somewhere and you are getting 1 by 100 to the power some and like 2, 3, 4. You know the power of 0.0001. of this will result 0.00008 times zeros and then 1, right? So
Yes,
you
sir.
can try to neglect the entities which are going to be very small in future. Okay,
Okay, sir.
this is just an approximation. Okay, you want to be directly getting where I should neglect the thing. When you solve too many questions, you will get it. Okay, and I will suggest you to solve all those 22 questions, and you can skip the complex number wala question. Okay?
Okay, sir.
I
Yes,
saw one question from the complex number part. Except that, I think you can try all of them. Okay.
okay, sir.
On 16th, what I will do, I will take your doubts. Okay, like what doubt you have in all those questions. We'll solve those questions. Then we'll move to the rest of the topics of the binomial theorem. All the topics are not left. Just some of the derived theorems are left. Okay.
Okay, sir. Yes, sir.
Okay, the derived results are there. If you know them directly, you don't have to mug up with all the basic fundamental and what I can say the primary method we used to solve. Okay, so that's the thing. Any doubt you have in the class?
No, sir.
It's all right, right? Okay, so I think I can end the session if you don't have any doubt.
Yes, sir. All sir.
Okay, so yeah, goodbye. We'll take the next class on the 17th. Okay,
Okay, sir.
16th actually, not the 17th.
Okay, sir. Yes.